landfill space is rapidly reaching a tipping point. Some of this waste can be recycled, but the more complex the product, the more difficult it is to break down. Car windscreen glass, CDs, and expensive bike parts are just some of the products deemed unrecyclable. Engineers and material scientists at UNSW are turning these unrecyclables into new green alloys for industrial use. An alloy is a mixture of elements. A parent metal like iron is combined with another element such as carbon to give it superior strength and hardness. This makes them perfect for making industrial tools like drills, diggers and cast iron pipes.
We want to reform our waste so that ultimately it's not seen as a plastic or a glass, but it's actually seen as a resource of elements. So in plastics we've got carbon, in glass we've got silicon.
So it's like reincarnating?
Well, actually it is a reincarnation of the product.
And to encourage local industries to recycle, Professor Veena Sahajwala sourced bike parts from David Musgrove.
It's quite ironic that bicycles are considered an eco-friendly form of transport, but actually some of the high-end bikes are made of carbon fibre and they're currently not recyclable. Hi Veena.
Hey, how are you?
Yeah,
I'm going to hand this to you. Good to see you again.
Good to see you again, for sure.
So you've got some samples for us, huh?
Yeah, I do.
Yeah, that's good. That's good. What have you got for us this time?
A carbon fibre frame once again.
Yeah. Thank you so much.
But also I've got you a bunch of CDs
that
you talked about.
Yeah, fantastic.
The aim is to recycle the carbon from the CD or bike part and combine it with the parent metal, iron, to form an iron-carbon alloy. The iron sits on top of a tiny piece of bike part. It's inserted into the furnace and heated to 1550 degrees Celsius. At this temperature, the carbon atoms from the bike part transform from a complex solid structure to highly ordered crystalline carbon. This gives the carbon a better chance of reacting with the iron.
So there's the interface between the solid carbon and the liquid metal. The carbon atoms from this composite are actually dissolving into liquid metal, and you're then converting iron and making it into an iron-carbon alloy.
They have found that this process is faster and is therefore more efficient than using coal, the traditional source of carbon. This is because coal retains its disordered carbon structure even when heated and is slower to react with liquid iron. But the key point here is that they're transforming waste materials.
What we're really trying to do here is look at the process by which we arrive at the end product by using waste resources as our raw materials. That's what I was thinking,
They're also testing silicon-based products like car windscreens.
We actually have a pellet that contains waste windscreen glass and plastics mixed together. We want the silicon to come out of that glass because we want the alloy to contain silicon, and we can start to see these shiny droplets. And of course, that's your reaction product. And ultimately, the goal here is transforming the waste windscreen glass and the plastic into a green alloy that contains silicon and carbon. The icing on the cake for me really is about the fact that you can actually take end-of-life resources, free up those elements that were present as plastics and glass, and convert them into completely different end products like the iron-based alloys. You've transformed it and given it a whole new life.
But the real test is whether this research can be taken from the lab into the factory.
So yes, it's absolutely possible to take the findings in the lab, work in partnership with industry, and apply that new knowledge out into industrial processes.
We consider it extremely important to reduce the carbon footprint, and we have already produced a number of small castings in our laboratory. If the material is suitable for use in the castings, If it's cost effective, we'll certainly be very interested in putting such a product into production.
It gives people a whole range of new ways in which to transform those waste materials that we've been putting away into landfill and creating new value-added materials. So good for the environment, good for the economy.